Alright, we are talking about points, lines, and planes today. Unfortunately, on the video, you won't have the benefit of some of the visuals and things I will do for the class, but you still can get a lot from what we're going to go through. And you can always come in, see me for tutorials to get the visuals and explanations that you can't quite get through the video. Alright, so these are kind of the basic building blocks for geometry. We need to know what these things are. A point is an exact location in space with an indefinite shape or size. It's represented by a dot. It has zero dimension, has zero size. A point is only giving you a location. It does not have like a physical body and presence. It is a location only. It is represented by a dot, and we name points with capital letters. So, for example, this could be point A. Now, how you name it is just with the capital letter. And when you write the name, you don't have to write point. You don't have to write any symbols for it. You just write the capital letter. Okay, the next thing is a line. A line is an object with no thickness that extends indefinitely in two directions. Another word for that would be infinitely. And it has one dimension. It has a length to it. Now, because it extends in both directions forever, we put arrows on here. Obviously, we can't draw this thing forever. We'll run out of paper. And even if we could get enough paper, we would run out of our lifetime before we would finish because it goes forever. So we just put arrows to show that it keeps going. And while this mark on the paper has some thickness to it, a real line does not have any thickness at all. The only reason it has any thickness here is we need to be able to see something on the paper, and if we don't give it a little bit of thickness, then we won't be able to see it. Okay, but a real line has no thickness. Now, there are more than one ways to name a line. The most common way we'll use to name lines is with 2 points. You need 2 points to name a line. Now, there could be 20,000 points on this line. You could pick just 2 of them, any 2, and put them in any order you want. Obviously, I'm not going to put a ton of points on here, so I'm just going to put 2 points on here. There's 2 points on the line. I can call this line AB. Now, when I name the line, it is important that I put a line symbol over the top. And remember, a line has 2 arrows, so you make sure you put 2 arrows on it. And so if you see this, you would read this as line AB. Now, because a line goes to infinity in both directions, order doesn't matter. It doesn't have a beginning or end, so I can put these letters in any order. I could also call it line BA if I prefer. Now, these are 2 different names, but they're not 2 different lines. They're 2 different names for the same line. So if your name is Joseph and you also go by Joe, it's not 2 different people. It's 2 different names for the same person. Now, one other way that we'll name lines, and we won't use this as much, but another way we can name a line is there could be a small script letter or small cursive letter next to one of the arrows, and we can use that to name the line. So we could call this line L. So there's 3 different names now for the same exact line. Alright, a plane is a flat surface that extends infinitely in all directions. And a plane is 2 dimensions. It has a length and a width. A common thing that you could visualize as a plane would be a piece of paper. Now, technically, a piece of paper does have a 3rd dimension, but a piece of paper is so thin that it's almost like that 3rd dimension isn't there. So a plane is 2-dimensional. It's got a length and a width. It's a flat surface. Now, a plane extends infinitely in all directions. So think about being in a room in a building. There are walls that close off your room, but the floor does not stop when it hits the wall. We see the walls are kind of like the lines on the paper. I'm going to draw a plane here. This is the way you'll typically see a plane drawn. It looks like a parallelogram. Okay, and it's drawn at this angle because they're trying to give it the 3-dimensional look, like it's going off back into space. But think about the floor. it doesn't stop when it hits the wall. That same floor continues past the wall into the next room, right? So these are like the walls. You know, we draw this way so we can see it on the paper, but the plane doesn't really stop here. It keeps going this way. The plane doesn't stop here. It keeps going this direction. It doesn't stop here. It keeps going this direction. And all four directions, it extends to infinity. Okay? Now, a plane can be named more than one way. The most common way will be with 3 points. You add 1 point for a point, 2 points for a line, 3 points for a plane. Now, it's important that those points are not all in a straight line, otherwise all you're getting is a line. So here are 3 points on this plane. I can call this plane RST. And when I'm naming a plane, I don't have to put any symbols or anything. I can just say RST. That's understood to be a plane. Now the order doesn't matter. So if I wanted to call this TSR, I can do that. I could call it STR and so forth. Any combination of those 3 points will give you the name of that same plane. And again, these are not different planes. These are the same names for the, or excuse me, they're different names for the same plane. Now, just like with the line, we can name with points. We can also name with a script letter. Now, for a line, it was a lowercase script letter. For a plane, they will use a capital script letter in the corner. So we could call this plane P. Alright, 2 vocabulary words. One I already kind of told you about without using the word. Collinear means points that lie on the same line. So A and B are collinear. They're on the same line. Whenever we are naming a plane, remember the 3 points cannot be collinear. They cannot be on the same line. So we call that non-collinear. So when you're naming a plane, you not only need 3 points, but they need to be non-collinear points. Non-collinear points. Okay, if collinear means that they are on the same line, coplanar means points that lie on the same plane. So RS and T are coplanar. They're all on the same plane. Okay, in geometry, we're going to use a lot of postulates and theorems, and these are things that are facts, basically, for us. The difference between the two, postulates are statements that are assumed to be true. We'll get to theorems later, but postulates are theorems that are assumed to be true. These are the most basic, fundamental things in geometry. If you're going to have an argument about something, or you're going to try to prove something, you have to have facts to use to do that. You can't just say it's because and prove something. And so these are things that we had to assume are true at the just basic common sense level, and so that we have some things to use to prove other things later. Okay, so the following are postulates concerning these 3 basic elements in geometry, which it's referring to: points, lines, and planes. Alright, a line contains at least 2 points. Remember, we needed 2 points to name a line earlier. Every line contains at least 2 points. Through any 2 points, there is exactly 1 line. If I give you 2 points, here's a point, here's a point, there is always exactly 1 line that you can draw through those points. There's never a situation where you can't draw a line through 2 points, and there's never a situation where you can draw more than 1 line. If I give you 2 points, you can always draw exactly 1 line through those 2 points. A plane contains at least 3 non-collinear points. Remember, you need 3 points to name a plane. And they can't all be in the same lane, or excuse me, in the same line. They can't be collinear, because if I have 3 points all in the same line, I've only been given that 1 dimension, a line. I need 1 point to come off of that line to provide that 2nd dimension to create a plane. So through any 3 points, there is at least one plane. And through any 3 non-collinear points, there is exactly one plane. Now this is where I have a visual for the class, but I can't really give that to you on the video. Understand that if the 3 points are collinear, if they're all on the same line, there's actually an infinite number of planes that can go through those 3 points. If the 3 points are non-collinear, there's only one, and there's exactly one. Alright, space is a 3-dimensional thing. Okay? Just think, that the air in the room. It's a 3-dimensional thing. And 3-dimensional space contains at least 4 non-coplanar points. So just like when we needed to go from 2 dimensions, or from 1 dimension to 2 dimension, when we wanted a plane instead of a line, we needed that 3rd point to be off the line. We needed the 3 points to be non-collinear so we could get that 2nd dimension and create a plane. Okay, same type of concept, just 1 dimension bigger now. 3 points makes a plane. You need that 4th point to be off of the plane to give you your 3rd dimension. So you need 4 non-coplanar points to create space, to create a 3-dimensional object. If 2 points are in a plane, then the line that contains the points is also in the plane. Remember, 2 points creates a line. So if both of those points are on the plane, then the line going through those points is going to be on the plane as well. If 2 planes intersect, then their intersection is a line. Again, here is a visual that I will give you in class. I'll try to draw a picture here for you, but it won't work nearly as well as it won't work nearly as well as giving you the visual in class. Okay, now what I am trying to accomplish here is the look of 2 planes intersecting. So you have one plane right here, and you have another plane right here, and those 2 planes are intersecting each other right along this space right here. So here is a point that is on this plane and on this plane. Here's another point that is on both of the planes. Every point on this line is a point that is on both planes. So that is where the intersection of the 2 planes is. Now notice that I extended this beyond these endpoints here. Remember that planes, while when we draw them on paper, look like they have boundaries. They look like they have walls. Remember, a plane really extends to infinity in all 4 directions. So as this plane extends this way, and this plane extends this way, so will their intersection. So the 2 planes intersect at a line. And if this is not making sense to you, come see me and I will give you a better visual demonstration of this. Okay, so all of those were postulates, things that are assumed to be true. We got to know that those are all true so we can use those things to prove other things. And those things that we prove are called theorems. Theorems are important statements that are proven to be true. So these things had to be proved, but for us, they've already been proven, so we know that they're true. It's like scientific facts. It's something that's been shown to be true over and over and over and over again, and we know these things are true. So, the following are theorems about the 3 basic elements in geometry. If 2 lines intersect, then they intersect at exactly 1 point. Anytime you have 2 lines intersect, they're going to intersect at a point. So here's a line, where'd they intersect? At a point. 2 lines always intersect at a point. Alright, if 2 lines intersect, then exactly 1 plane contains these lines. If you have 2 lines that intersect each other, there will be exactly 1 plane that has both of those lines on the plane. Okay, so let's take some of this information that we learned and let's do some examples down here. The first thing we want to do is name 3 points that determine plane J. So notice the J in the corner. This is plane J. So one way to name a plane is with the script letter in the corner. Another way to name a plane is by 3 points. You need 3 points to name a plane. So we're naming 3 points. We're not actually naming the plane, but we're naming 3 points we could use to name the plane if we wanted to. So when I look at plane J here, I see 3 points on that plane. I see V, W, and Z. Now there's another point that would actually be on the plane, because remember, planes extend to infinity, and because both of these points are on the plane, this entire line is on the plane, then I know that U will also be on this plane, because as this plane extends just like the line is doing, U is still part of that plane. So I actually have 4 points to choose from, and I just name any 3 of those. It just said to name 3, it didn't ask me to name 4. So I'm still just going to go with V, W, and Z. V, W, and Z. Now, if it had asked me to name the plane, I would write V, W, Z together without any commas, but that's not what it asked me to name. It asked me to name 3 points. So these are 3 individual points. So I separate each one with a comma to show that they are points. Okay, next we want to name the intersection of planes J and K. So here's plane J, and see the K here, this is plane K. Where are those 2 planes intersecting? Now remember that 2 planes always intersect at a line. So this plane and this plane are intersecting at this line. So we want to name this line. Now when we name a line, we need 2 points. Well, I have 3 points on this line. Remember, for a line, when you name it, it can be any 2 points on the line. And they can go in any order that you want. So you could call it line UV, you could call it UW, WV, WU, whatever. You just need to pick 2 points on the line to name the line. So I'm just going to go with UV. And when you name a line, you always have to put the line symbol over the top, and a line always has 2 arrows. Make sure you got 2 arrows on that thing. So I named it line UV. You might have a different name and it might still be correct. Make sure you are not using points X, Y, and Z though, because none of those are on this line. Make sure you're using 2 of these 3 points, U, V, or W. Alright, number 3. Name a set of collinear points and a set of non-collinear points. Okay, remember, collinear means that there are points on the same line. So if we want to name some collinear points, we need points on the same line. Well, we just talked about this line right here and the fact that it has 3 points on it. So those 3 points would be collinear. U, V, W. Those are 3 collinear points. Then we want non-collinear points. So we want points that are not on the same line. Now, for a group of points to be non-collinear, it only takes 1 point not to be on the line. So if I listed all 3 of these and then just picked one of these others, those would be non-collinear because none of these points are on the same line as these 3. There's no one line that would go through all 4 of those points. But I don't have to do that. There's a lot of different combinations I could come up with here. Just pick 3 or more points that are not on the same line. It's got to be 3 or more. So if you only pick 2, remember there's always a line that goes through 2 points. So if you're naming non-collinear points, it's got to be at least 3 points. So I'm just going to say X, Y, and Z. There's not one single straight line that's going to go through all 3 of those points. X, Y, and Z. Those are 3 non-collinear points. Alright, name a set of points other than those in example 1 that are coplanar. So we said V, W, and Z were coplanar because V, W, and Z were all on plane J. Alright, let's name a different set of points that are also coplanar. Well, what about plane K? Remember, V and W are on the intersection of the 2 planes, so they're part of this plane. U is as well, and then Y is also part of that plane. So another set of coplanar points would be V, W, and Y. And again, you could include U if you wanted to as well. Notice it didn't say number of points, so you could do 3 or 4, doesn't matter. There's an example of points that are coplanar that's different from example 1.